Hello, advanced algebra students. Welcome back to more solving systems, where today we are going to be focusing on how do we use systems to solve story problems. So we've got one of the more classic type of problems here from your packet. I believe this is page 4 of the packet, number 4. It reads, for the school play, adult tickets, which we're going to label as A, sell for $5, and student tickets, which we'll label as S, sell for $3. On Saturday, a total of 390 tickets were sold, and the total receipts were $1,530. How many adult tickets were sold? How many student tickets were sold? So hopefully you can see we've got kind of two missing pieces: how many adult tickets were sold and how many student tickets were sold. And so we've got two missing variables, two missing pieces, which means we need to come up with two equations, at least two, if not more. That'll help us either use substitution, elimination, to potentially. And so we know that A is going to represent the adult tickets. At least that's what it says in the story problem. And then S is going to represent students. And then we've got to kind of use the information in the problem to see if we can't come up with two different equations. Two different equations that'll help us solve. One of them, it says that a total of 390 tickets were sold. A total. So that means the adult tickets, let me get rid of that horrible A. The adult tickets plus the student tickets, adult plus student tickets, totaled 390 altogether. The second equation comes from what their value and money was. Okay, we know that somehow they made a total of $1,530. Well, how do we get that? Well, we charged $5 times every A ticket, so 5A, plus it was charging $3 times every student ticket. 5A plus 3S is going to equal 1,530. So as you can see, we now have those two equations. And once we have two equations, we can choose a method to use to solve. I am going to use elimination by multiplying the top equation by, why don't we do -3? All right, by -3. That gives me -3A plus -3S equals 390 times -3 is -1,170. Not going to do anything to the second equation, just going to leave that alone so that I can use elimination, because now the S values will eliminate if I add the two equations together. -3A plus 5A is 2A. -3S plus 3S cancels. And -1,170 plus 1,530 gives us a total of 360. Meaning if I divide by 2, adult was going to be 180 tickets. 180 tickets. All right, so we set up two equations, we found the adults. So we answered this one. However, it still wants to know about how many student tickets were sold. So I'm going to take that information And I'm actually going to plug that 180 right back into here because I know the number of tickets, adult and students, was 390. So 180 plus the number of student tickets sold had to equal 390. If I subtract that 180 from each side, that means the number of student tickets sold was going to be 210 tickets. 210 tickets. So as we talk about story problems, we may not necessarily need to use the ordered pairs. We might want to explain our answer, right? There were 210 student tickets sold and 180 adult tickets sold. So we might want to really truly explain our answer as best as we can. All right, so we got to peel back from the equation or the story problem to come up with those two equations and then use one of our methods to solve. The next one is from your packet, but it goes backwards to number 3. It talks about Kauffman Stadium has a seating capacity of 4,216 people. There are 4 times as many lower level seats as there are upper level seats. Also, there are 3 times as many bleacher seats as there are upper level seats. How many seats of each type are there? Hint, there are 3 equations. So again, understanding the question, how many seats of each type? Each type. We have 3 types. We have lower level, which we're going to say is L. That's the lower level seats. We have a U for the upper level. And then we are going to use B for bleachers. So that is what I gathered from reading the story problem. Those are the 3 types of seats. Lower level, upper level, and bleachers. So I know that there is a seating capacity of 4,216. 4,216. That's the whole entire stadium, which means if I take the bleachers plus the upper level plus the lower level, if I add all 3 types of seats together, I should get that total of 4,216. Now, the next 2 equations are what tend to be the trickiest. There are 4 times as many lower level seats as there are upper. 4 times as many lower level as there are upper. So which one do we have more of? Do we have more lower level or do we have more upper level? In this case, we have more lower level. There's 4 times more of them. So my lower level is 4 times the amount of the upper. All right, so hopefully you can understand how I process that, right? There are 4 times as many lower. The lower has to be larger. So I've got to do 4 times the upper to get that. Then there are 3 times as many bleacher seats as there are upper. So the bleacher seats have to be more than the upper, meaning the bleacher is 3 times the upper. 3 times. Sorry, shouldn't be subtraction, should be times. Okay, so now I've got 3 equations, right? And the important part here was that we had 3 missing variables, which means we should have 3 equations. That's the only way I can somehow get them all to eliminate. Now I'm going to use substitution because I've got L that has a U in it, and I've got B that has a U in it. So I'm going to take this for U, and plug it in for L, and I'm going to take this 3U and substitute it in for B, right? B is that, L is that, which means 4,216 equals, it said B originally, but we're going to say that that's 3U plus another U plus the L, which we now are substituting with 4U. So we've taken that original equation that we had up there on top and using substitution got it down to one variable, which is what we want. We want only one variable so that we can solve. So if I look at this side, 3U plus another U plus 4U gives me a final of 8U equals 4,216. We're going to solve that by dividing both sides by 8. So 4,216 divided by 8 gives me 527U equals U, or the upper seats. And now let's use that to find our lower and our bleachers. The lower equals 4 times the upper. 4 as many times 527. Whoops, 527. So my lower is equal to 2,108. My bleachers had to be 3 times U, 3 times the upper. If I take 3 times 527, I get 1,581. All right, I'm just going to double check my answers though by plugging them into this top equation, right? Does the amount of bleachers, 1581, plus the amount of upper seats, 527, plus the amount of lower seats, 2,108, if I add all of those together, does that indeed equal the 4,216? Using my quick calculator, it certainly does. So that means, if we want to type this out quick, again, it's a story problem, so we should probably, describe our answer. There are 527 upper level seats, 2,108 lower level seats, and 1,581 bleacher seats. We want to be able to describe those answers when we get them for a story problem. So we're still using systems, we're still going through substitution and elimination, but we're trying to create the equations first from the information that is given. If you have any questions, make sure you reach out to your teacher. Otherwise, keep up the great work, and we'll see you next time. Stay safe.